Welcome back to the Tool Crib. In today's video, we're going to be talking construction calculators. And I love construction calculators. I have several from Calculated Industries, including the Construction Master 5, which was my first one. And I have the Construction Master Pro Trig and the Pipe Trades Pro. Invaluable tools. Absolutely invaluable. They save so much time. But when it comes to these two in particular, they have one flaw when it comes to carpentry, and in particular when it comes to framers, and that is how it calculates jack rafters. Well, today I'm going to show you why the calculator is wrong, and then how you can make some different inputs in order to correct it so that it spits out the right numbers for you. Let's get started. Now, when it comes to roof framing, your rafters are going to be set on 16-inch centers, and there's several different types of rafters. You have the common rafters, which sit perpendicular to your ridge board. Then you have your hip rafters, which in a standard hip roof will sit 45 degrees to the common rafter. And then you have jack rafters. Now, jack rafters are defined as rafters that extend from the hip rafter to the plate, and these are cut on a 45-degree angle called a cheek cut. Now, the calculator does not calculate the jack rafters correctly. It does the commons correctly and it does the hips correctly, but the jack rafters are not. So we're going to do an example here, and we're just going to give an example roof, and we're going to calculate what the distance should be for the jack rafters, and then I'll explain to you why the calculator gets it wrong and the corrections you can make to make it right. Okay, so in our example roof, we're going to say that the pitch of the roof is an 8/12 pitch, and for brevity's sake, we're just going to say it's an even 12 foot. And let's clear the calculator first so we make sure that we don't get any bad inputs. The way we input this into the calculator is like this: 8-inch pitch, I'm going to put it in inches, 144-inch run. Then we can hit the diagonal, and that is going to tell us the length of the common rafter, in this case 173 and 1/16. And then if we continue to hit diagonal, it'll give us the plumb cut and the level cut. Then if we move over to the hip, it gives us the length of the hip rafter. It'll also give us the plumb cut and the level cut for the hip rafters, and it'll tell us the cheek cut, the double cheek cut at the bottom of the hip rafter, which in a standard hip is going to be two 45-degree angles. Then if we hit the jack rafter, it's going to tell us that our jack rafter spacing is 16-inch on center, and that is correct. Then if we hit jack again, it's going to tell us the increment that the jack rafters are shorter from one another. So the distance from here to here, that length difference is going to be 19¼ inches on our example roof, and that is also correct. Where it is wrong is in the placement of the first jack rafter, which shows the length at 153 and 13/16. This is actually about a ½ inch longer is what it should be. Now, because the first jack rafter is wrong, all the spacing for all the other jack rafters is also going to be wrong. So if we had a 45-degree hip here, and we'll just try to do a quick drawing of this, your jack rafter is going to have a cheek cut of 45 degrees. Now, the measurement between here and here, you'll usually measure to the long side of your jack, is going to be 16 inches. But the problem is right up here, and I'm going to blow this up, and I'm going to show you exactly why the calculator gets this wrong. Why, I don't know why it doesn't figure it in, but I'm going to show you why the calculator gets this wrong and how to correct it. So here I have a blow up of the connection point at the top of the ridge where your ridge board, king common, common rafter, and hip rafter will all converge. And when you're using standard lumber, dimensional lumber, all of these rafters are going to be 1.5 inches wide. So this is the plan view of that connection point. Now, you'll notice that I extended the center line of the hip rafter up and through, and also extended the side of the hip rafter up and through. And we can very easily see that where the common rafter meets the ridge board is not the same point where the hip rafter would extend through the ridge board. And I've also heard this said that what the calculator does, it actually does a theoretical center. Well, that's not correct either. It actually doesn't calculate to the theoretical center either. And because we're using dimensional lumber, this is fairly easy to prove. So building on the last video that I showed, using the Pythagorean theorem, we can very easily calculate all of these different lengths. And I can tell you that this distance here is going to be equivalent to 0.439 when using dimensional lumber. So the way we do this is like this. All of these triangles, so this triangle here, and this triangle here, and this triangle here are all 45-degree angles. So because we know the dimensional lumber, we can figure this one out. So this will be 0.75 x squared plus 0.75 x squared will get us that value. Now to get the true value, we have to take the square root of that, which is going to be 1.06. So now we can write this in. This is going to be 1.06, or about 1 inch and a 16th. Now, because this is a 45-degree triangle, that means that this side is also 1.06. That means that this distance is 1.5 inches minus, or this distance here will be 1.5 inches minus the 1.06. So if we take that number, we subtract 1.5 for the thickness, then we get 0.439. We'll just switch that to positive, and now we know that this is 0.439, which means that this distance here is also 0.439. So the way that you correct this in your calculator is like this. You would have to add, you can put your inputs in to get your common rafter and king, or hip rafter, and the king common are all correct. But when you go to do the jack rafters, if you want all of them to be correct, you have to add back 4.39 inches, because when you're measuring 16 inches from this side of the common rafter over to this point of the high side of the cheek cut for the jack rafter. And your jack rafter would sit in here like this with a 45-degree cheek cut, and you need the center lines to make up exactly 16 inches on center. So in order to do that, we have to go to the theoretical point if this common rafter extended through where the hip rafter would meet it. So the way we do this is, let's clear this out, and we'll go back to our 8-inch pitch, and this time it's going to be 12 feet. Actually, let's do it in, let me clear that out again. We'll do it in inches so we can get it more accurately. We'll do 8-inch pitch, and then it'll be 144.439 inch run. Now when we hit our jack rafters, we'll start off with 16, and now our measurement is going to change, and now it's going to put it in decimal form, which I actually like better. The first jack rafter will be 154.36. 154.36, and then from there on, all of your successive jack rafters will be in the right position. So let's clear this out. I forget what the original measurement was. We'll do 8-inch pitch, 12-foot run, and then hit our jack rafter. And the original was 12 foot 9 and 13/16. We hit inch. That was 153 and 13/16. So you can see that if we hit it again, I think I'll put it in decimal. 153.83. So you can see that there is about a ½ inch. It varies as the pitch changes. It's going to change how far this number is off. Now let me show you how you can very easily calculate according to each pitch what that number is going to be, in case you didn't want to do it on the Construction Master Pro. So I'm going to do this with the trigonometry. It's just a little easier for me. And for those that aren't versed in it, I'll try to give you a rundown of what we're doing here. So our pitch is 8 divided by 12. The first order of business is to figure out what this angle is. And to do that, we're going to use the tangent function, because we have to label this triangle. This is our adjacent from our angle. This side is the opposite. This is the adjacent, and this is the hypotenuse. So we have to use a formula that has two values that we know and one that we don't know. And that's going to be the tangent function. So this will be written out like this. Tangent of our angle, when we don't know the angle, we call it theta, will be equal to the opposite side over the adjacent side, or our pitch. Now, to get the angle by itself, we have to take tangent across the equal side, and that becomes tangent to the -1. So let's do that, and we'll figure out what our angle is. So we take, let me clear this out. We take 8 divided by 12 equals, and then we hit the second button and then hit tangent to the -1 and then hit equals, and that's going to tell us that our angle is 33.69 degrees. So 33.69. Now we'll just move it over here. It's consider this the same triangle. What we're ultimately trying to find is what the multiplier is for this side. So when we know the run, what do we multiply the run by to get the rafter length? So now, in order to do that, we have to change our formula. This is going to now be cosine, and now we know the angle. That's going to be 33.69. Will be equal to the adjacent side, which we are trying to find the value for, and it's automatically going to set the value for the hypotenuse or the rafter length at 1. So then if we just take the cosine of this angle, that's going to tell us that this side length is 0.83205, and this side will be 1. So another way to say that is that the run will be 83.2%, the length of the rafter. But we want this value to be 1 so we can get the multiplier. To do that, we take the reciprocal of that, which is 1 over x, hit equals, and that tells us that the multiplier is 1.20185. So now we can, let's clear our memory and we'll put that number in our memory. Now, you can also write this formula out like this, and it'll get you the exact same result. Now that we know our multiplier, now we can take our run, which our run was 12 feet, so by 144 inches, times 144 inches. That'll give us our rafter length. And then we can clear this. Now if we multiply it by that 0.439, that'll tell us for this particular pitch how much shorter, or excuse me, how much longer our first jack rafter needs to be in comparison to what the construction calculator is showing us. So we take the multiplier, which was 1.20185, and multiply that by 0.439, and that tells us that the jack rafter, the first jack rafter, actually needs to be a little over a ½ inch longer than what the construction calculator was showing us. Now you can also do this in the construction calculator. So let's clear this out, and we're going to set our pitch the same, 8-inch pitch, and we're going to set our run is going to be 0.439. 0.439 inch run. And then we hit we hit the diagonal, and that'll tell us we get the same number, the 0.527612. And I believe that should be exactly what we got on our calculator. So you can do it with either calculator. Just change your run to 0.439, and that will tell you exactly how much longer the first jack rafter needs to be. Now, let's say that you're using material that is non-dimensional lumber, where this might be wider, like you're in timber frame construction or something, and you're using a lot wider material. Well, the way that we calculate what this distance will be is you take the material thickness and then you subtract 1/2 of the material thickness times the square root of 2. So this is half the material thickness times the square root of 2 will get you this number, which is here. If you take the width of your material on the common rafter, subtract this number, you'll be left with this dimension, which is also this dimension, and so then you'll know how to make those corrections. So let's do it with the standard dimensional lumber. So we'll take our material thickness, which is 1.5 inches, and then we're going to subtract half of the material thickness, which is 0.75, multiplied by the square root of 2, and that will get us 0.439 inches. Now, obviously, if your material is thicker, so let's just do 3-inch. If we do 3-inch and we subtract 1/2 of that times the square root of 2, then we end up getting 0.878. So as the material gets wider, this number will change. But for standard lumber, whenever you want to get the jack rafter placements correct, this is the best way to do it so that you can very easily, it just adds to it. it's going to place the jack rafter in the right spot, and then the placement between jack rafters, it calculates correctly. So that's not an issue. You just need to add 0.439 to the length of your run in order to make your jack rafters come out correctly. I hope this helps for those that are in roof construction or roof framing. It's unfortunate that these calculators do not make that adjustment, but it's an easy problem to overcome if you understand the math behind it. And hopefully this little demonstration kind of showed you how to calculate all of that. I appreciate you guys taking the time to watch. I'll see you in the next one.